Hello again. This is Math 2233 coming to you from the College of DuPage. And the title of this lecture is Midterm Solutions, Grading Rubric, and pointing to an upside opportunity looking forward. As always, please be an active learner as you watch this video. Just a comment, one of the reasons that I don't let you use calculators like this is these do have symbolic integration on them, and the math department has a policy that they don't want students in calculus classes using symbolic integration, and so I had to outlaw this calculator and other calculators that have symbolic integration. That's why you're restricted to using Excel or the calculator on your PC or some other calculator that doesn't have symbolic integration, and almost all calculators have symbolic integration now, so those are the reasons why. Let's quickly go through the key. Number one, you were to find the velocity, speed, and acceleration of a particle whose motion in space was given by this vector equation. And you're supposed to find this at a specific time. Again, I like numbers, so these are the kind of problems that I usually will ask you. So what we do is the velocity is the first derivative of this. So I take the first derivative and simplify it a little bit. There was a trig identity involved in going from this step to this step. And then I take another derivative because the acceleration is a second time derivative, and I get this. And so those are the velocity and acceleration equations, and speed is the magnitude of the velocity. It is not, it doesn't give you direction. So the magnitude of the vector v is this. Sine squared plus cosine squared is 1, and so when you will do that, you will get 4 for that part, and then it's 25 sine squared of 2t, and we're going to plug 7 pi over 4 into all those. This is what you get for the velocity. This is what you get for the acceleration. And this is what you get for the speed. And number two, you were to find the distance from a point to this line. So, so there's the equation for L, and we know if we take t to be equal to 0 that this is a point on the line. And we know that the direction numbers for this line are given by being parallel to this vector. So we have 1, -1, and 2. Those are the coefficients on the t. So that means if I took that point and between that point P that was on the line and S that's not on the line, I get this. And so PS is given by this vector. And so then I know from the equation that we had in the book that the distance from the point S to a line L is given by this expression. So I'm just going to calculate this. So I take PS crossed with my V, and this is a cross product. I do the simplifications and I get this. Then I divide by the magnitude of V. So I take the magnitude of this divided by the magnitude of V and do the calculation. I get the square root of 5. Here we were to find a vector parallel to the line of intersection of these two planes. So the line of intersection of two planes is perpendicular to both planes' normal vectors, n1 and n2. And if you want to think about that for a while, here's a picture that can help you from your textbook. Therefore, it's going to be parallel to the cross product because the cross product is normal to both of those, so it's going to be parallel because it is perpendicular to the same line. Okay, so that means that n1 cross with n2, then that gives us the direction is a vector parallel to the plane's line of intersection. So we just compute n1 cross with n2. I get those directly from reading the equations of the planes, and I get this. This certainly is a correct answer, but any non-zero scalar multiple of that will do as well because that's the same direction. Problem 4 is a projectile motion problem. The first part, you were to find a vector equation for the path of the baseball. what you're going to do is you're going to say the acceleration in the j direction is the acceleration due to gravity, which is going to be minus 32 feet per second. And so we integrate that, but we know my initial velocity from the information that's given. So my initial velocity is this. And if I integrate again, I get this, but I know my initial vector is 0i plus 3j. So basically what I'm doing is substituting all that stuff in. So the position is r is equal to, here's the 3 in the j direction. This is going to be, and I have velocities going in the I and j direction, and I simplify terms and I get this. So this is the expression that we were looking for part A. Now, the ball reaches its highest point when the vertical component of velocity is 0. You see it's going up, that's increasing velocity, or I mean increasing height. So the velocities are still going up, but they're decreasing because gravity is pulling it down. But eventually it'll stop being positive and start being negative because what goes up must come down. So the maximum height happens when this velocity is 0 in the y direction. So dy dt is equal to this component. So I can solve for t, and I find out that t is 1.62 seconds. And I can substitute that into the vertical component for r, which gives a maximum height of, when you do the calculation, 45.2 approximately. So these were your answers for part B. If the ball wasn't caught, you wanted to find its range, how far did it go horizontally, and its flight time. Okay, so to find out when the ball lands, we set the vertical component equal to 0 and solve for t. And this was the vertical component. We solve this for t. This is solving a quadratic. One of the solutions is negative, the other is approximate, but it's 3.3. And again, you could use the quadratic formula because I let you have a calculator. So then we're going to substitute this into an equation that represents the distance that it goes. Notice that we are subtracting the 8.8 because that's the only resistance that happens there, and so I get 442 feet. That was kind of a long home run. So thus the horizontal range is about 442 feet, and the flight time is 3.3. So there were 1, 2, 3, 4, 5 answers to this problem. In number 5, you would find the arc length as t runs from 0 to 5 pi over 3 along the helix. This is the equation of the helix. And we know that the arc length is equal to the integral from 0 to, from my initial point actually, until whatever I have. So I'm going from 0 to 5 over 3. And this is the magnitude of the velocity. It's the speed, tells you how far we go, dt. And so that is then going to be, that's the speed along the arc length. And so it's going to be, and the speed is, I take the derivative of the, or the velocity is the derivative of this. So I get minus cosine of t, cosine of, minus sine of t, cosine of t, and I get 1 here. So it's the square root of those squared. And if I add those up, noting that sine squared of t plus cosine of squared of t is 1, I get square root of 2. I calculate this integral, and I get 5 square root of 2 over 3 times pi. And so that's the answer that you should have gotten for number 5. For the same helix that we just did, you wanted to find the unit normal vector. Well, the unit normal vector, what we have to do is we have to find the tangent vector. So we take the derivative of this, and when we take the derivative of this, we get minus sine of t, cosine of t, and 1. But then I have to divide this because this is the unit tangent vector. So I divide this by the square root of 2, which is what this length is, the magnitude of that vector. And then the normal is the derivative of that divided by the magnitude. Now the magnitude of this is 1 over square root of 2, so we're really just going to cancel out that 1 over square root of 2 when we do the calculation. But the derivative of this then is going to be the minus cosine of t, this is going to be the minus sine of t, and this is going to be 0. And then I wanted you to evaluate that at 5 pi over 6, so we plug 5 pi over 6 into there, and we get these numbers. So this is the answer to number 6. Number 7, we wanted to find the direction of this multivariate function. at a given point in a given direction. That means we wanted to find the directional derivative. Okay, so we need to change this into a unit vector. So the magnitude of this is going to be 7. So the unit vector in the same direction of v is this one. So then I'm going to take the partial of this with respect to x, and I'm going to evaluate it at that point, and the partial of this with respect to y, and evaluate it at that point, and the partial of this with respect to z, and evaluate it at that point. This didn't show up, but this has to be minus 1 there. And then, so that tells me the gradient is 2, minus 2, and minus 1. So this is the gradient. I take the dot product of the gradient with that unit vector that I found up here and do the calculation, and I get the answer is 4 over 7. Number 8, we were supposed to discuss the limit as xy tends to 0, 0 of f of xy. 4, and here was the function. And the answer is the limit doesn't exist, and you could have had different examples of this, but if I approach 0, 0 along y equal 2x, what will happen is I will get 4 x squared in the numerator, and in my denominator I will get 5x squared, so that's 4 over 5. But if I approach it along the line y equal x, I will get 2 over 2, which is 1. So if I go along this direction, I get 4 over 5. Along this direction, I get 1. So the limit doesn't exist because it depends on the trajectory over which you approach the limit point. Number 9, you were to do some calculations, and you were computing partial derivatives at a point. You're using the problem from the previous one, so you have to remember the quotient rule. So this is what you get for the derivative, and you plug a number in, and you got 12 over 25, or 0.48. When you do this second derivative, you take the derivative that you had here, and you take the derivative yet again of it, and you get this expression when you simplify it, and you plug the numbers in, and you get this, which could be simplified to that. So this is number 9. It's partial derivatives computation. Number 10, you wanted to find the tangent plane and normal line to the level surface. This is the level surface at this point, and there's a picture showing kind of what's going on. The tangent plane is the plane through that given point, perpendicular to the gradient of f at p0. So we have to find the gradient of f at p0, and when we do that, we get this is 2, 4, and 1. So that means that the tangent plane is going to have those direction numbers. So it is 2, and this is the point x minus 1. This is 4, y minus 2. And this is 1, and this is z minus 4 equal to 0, and it could be simplified to look like this. So that is the tangent plane. The normal line does go through that point, so it's 1, 2, and 4, 1, 2, and 4, but the directions are going to be 2, 4, and 1. So this is a parametric representation of that. You could have written it differently, but this is x is equal to 1 plus 2t, y is equal to 2 plus 4t, and z is equal to 4 plus t. So these were the two answers that you wanted to have for the problem. My rubric is I do treat the answer sheet in Blackboard as the primary grading instrument. So if I find the correct answer listed there, that'll be full credit. If I find an authentic answer but wrong answer, I will give partial credit, probably half credit, and I will look at your PDF to see if if you had sufficient work for me to give you the credit, and I'll probably be liberal on that. And then I'll convert your percentage to out of 100 for your score on the midterm. Now, relative to sort of where are you at midterm, I'm still in the process of grading these, although I expect to be completed well before the end of spring break, so you'll have a number there. But I want to talk to you about that in this video anyway. So what will happen is the college asks me to file something, and I just file S for satisfactory or U for unsatisfactory at midterm, because they want these things really early about where you are. Everybody was really in satisfactory condition going into the midterm. And so that's what I had to file with the college. Now, the real perspective about where you are is I'm being very generous with everybody in a column that I am putting into Blackboard called Low Stakes Assessments Year to Date. Haven't put this in yet, but I will, and I will grant everybody 100 because in the past my calculus students could use a good score. So this is a good score. Then you'll get your score on the midterm. Based on the papers I've looked at so far, I expect the scores in the midterm will range from 50 up to perhaps 100. And so I take the average of these two grades here because they are equally weighted at the end of the term. And again, we will have more low stakes assessment, but this was up to the midterm. So 100 and 100 is 100, and I'm just taking the straight up average of these things. And so if you land in this range, you are at an A. If you land in this range, you are at a B. And if you're in this range, you get a C at midterm. I mean, just about where you are. But now I have an offer for you that has a major upside opportunity. I want to encourage you to finish strong. As the final exam is comprehensive, I make it a practice to award a letter grade no lower than that earned on the comprehensive final exam. The comprehensive final exam, however, is mandatory. Now, this means that if you get an A on the final exam, you get an A for the course. If you get a B on the final exam, you won't get any lower than a B for the course, and so on and so forth. This is a significant upside opportunity, and I encourage you to take full advantage of this opportunity as we go forward. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other. May God bless you all.